Hi, my name is Ella, and today I'm going to be teaching you how to solve systems of algebraic functions with two variables. So to solve these systems, there are three main methods you can use: substitution method, elimination method, and graphing. We're going to start off with the substitution method. For this method, there are five main steps. First, you'll solve one equation for one variable, and then you'll plug that expression that you got for that variable into one of the other equations and solve for that variable. And then you'll replug the value you just got for that variable into one of the original equations to get the other variable. And finally, you'll check your answer. So I have an example for a substitution method. We'll use the equations 5x minus 2y equals 17 and 3x plus y equals 8. So we need to solve one of the equations for one variable. In this case, I'm going to solve 3x plus y equals 8 for y to get y equals 8 minus 3x. And then we're going to plug that expression that we just got back into the other equation of 5x minus 2y equals 17 to get 5x minus 2 times the quantity of 8 minus 3x equals 17. And we'll simplify it out to get 5x minus 16 plus 6x equals 17. And when we solve for x, we'll get 11x equals 33 and x equals 3. And now we'll plug what we just got for x, which is 3, back into one of the original equations. It doesn't matter which one you choose. It should lead you to the same answer. So plug it in. We'll have 5 times 3 minus 2y equals 17. 15 minus 2y equals 17. Negative 2y equals 2. So y will equal negative 1. So for this problem, we got x equals 3 and y equals negative 1. We're not done because we have to check our answer because you could have made a mistake in the process. To do this, you'll plug 3 in for x and negative 1 in for y into both of the equations. It's always best to do both the equations because sometimes your answers will work for one equation and not the other. But in order for the answer to be right, they should work for both equations. So plugging it into the first equation, we'll get 5 times 3 minus 2 times negative 1 equals 17. So 15 plus 2 equals 17 and 17 equals 17. That means it works for the first equation. So now let's figure out if it works for the second equation. We'll get 3 times 3 minus 1 equals 8. 9 minus 1 equals 8, so 8 equals 8. That means the answers of x equals 3 and y equals negative 1 are correct for this example. Now on to the elimination method. Again, there's 5 main steps. First, you're going to multiply or divide so that one of the coefficients on one of the variables are the same. So it doesn't matter if they're opposite signs like negative or positive, as long as it's the same number. And then you're going to add or subtract one equation from the other to cancel out that one variable and solve for the other variable. And then you're going to replug the value you just got for that one variable back into one of the original equations to get the other variable. And again, check your answer. So for this example, we have the equations 2x plus y equals negative 4 and 5x minus 3y equals 1. So first, we're going to multiply 2x plus y equals negative 4 by 3 so that we get 3y in one equation and negative 3y in the other equation so that we can cancel those two y's out. When we multiply 2x plus y equals negative 4 by 3, we'll get 6x plus 3y equals negative 12. And now we're going to add those two expressions together to get 11x equals negative 11. So solving for x, we get x equals negative 1. And now we're going to plug that negative 1 in for x in one of the original equations. I chose the 2x plus y equals negative 4. So I'm plugging in negative 1. We get 2 times negative 1 plus y equals negative 4. Negative 2 plus y equals negative 4. So y will equal negative 2. So for this example, we got x equals negative 1 and y equals negative 2. So we're going to plug those back into the original equations to check our answers. For the first one, we have 2 times negative 1 plus negative 2 equals negative 4. So negative 2 minus 2 equals negative 4, which leads us to 4 equals negative 4, or negative 4 equals negative 4, which is correct. So now we need to try the other equation. We'll have 5 times negative 1 minus 3 times negative 2 equals 1. Negative 5 plus 6 equals 1. So 1 equals 1. That means the values we found in this example of negative 1 and negative 2 are correct. And finally, on to the last method of graphing. In this method, there's only 4 steps. You'll start by graphing one equation, and then you'll graph the second equation. and you'll find where those two equations intersect, and then again, check your answer. For the graphing example that I have, the equations are y equals 2x plus 2 and y equals x minus 1. So first we'll start off by graphing y equals 2x plus 2, and that's what your graph should look like. And then we'll graph the second equation of y equals x minus 1, which is the one in green. And we're going to find the point where they intersect, which is where that circle is, and the coordinate for that point is -3, -4. So x equals -3, y equals -4, and we're going to check our answer. When doing this, we're going to plug -3 in for x and -4 in for y to get -4 equals 2 times -3 plus 2. So -4 equals -6 plus 2. So -4 equals -4. So the values we found for x and y were correct. And then moving on to the second equation, we get -4 equals -3 minus 1. So -4 equals -4. I hope this video was helpful and you learned something about solving equations with two variables. Thank you.